Welcome back to the finale and part 3 of the entire series. In this finale, we are going to see if Prometheus scraped our application properly, and then we will create a dashboard using Grafana. So let's get started. Now, in order to check if Prometheus scraped our application, we'll have to create another window. So let me expand the text. All right, so we're good to go. So we'll go to kubectl get svc and monitoring, and of course the one we actually want to use is here. Now we are going to use Prometheus. Now we could always use, we're going to use this. Prometheus, cube, Prometheus, Prometheus. So in order to run this, we're going to do kubectl port forward, and then we'll do Prometheus. Actually, it's better if I just copy this. So I will copy this to make this easier. We'll paste this. Let me just do this, and we'll do 9090. Now, of course, I can't forget this is an SVC, so SVC slash. Oh, and I forgot. And monitoring. So let's go to port 9090. So localhost 9090. And there we go. So what we can do now is go to status, and we'll go to targets and check it out. It's up. And the reason I can show you is because if we click on this, we show more. Let me expand the text a bit more so you can see. As you can see here, there is no error. Scrape duration is at 7 milliseconds. And the last scrape was 22 seconds ago. It gives us our container name, endpoint, instance, our job, the namespace, the pod, as well as the service. And the state is up. Here are some other ones, but the one that I'm concerned is with this one. Now, if this did not work, then this means that there's something wrong with the configuration, but this is good. So we don't need this anymore since we already know it works. Of course, let's blink the application a bit more so we can add some activity to our application. And of course, let's go to status just to make sure that works. And it says OK, healthy. But let's go to metrics to make sure everything's working. And it is. And it sees everything here. Now, let's go back to our main application. Now, in order to create an application, or at least a dashboard, we need to create, or at least open Grafana. So we'll go to, again, kubectl. Actually, we can do this in the same session. We'll just exit out of this, and we are actually going to use something else. So in order to use Grafana, we need to use this one. So kubectl port forward SVC Prometheus Grafana at port 3080. Sorry, 80, and then and monitoring. So, oh, I see. Apparently it typed twice. So we're going to port 3000. Let's exit out of this. So localhost 3000, and it should appear. And there we go. So our username is admin, and the default password is prom operator. But you need to change this for security reasons, of course. So here it is. We are now in Grafana. If you need help, there's some tutorials, documentation. So we're going to create our first dashboard. And to do this, we are going here. Now we're going to do new dashboard. So we're going to add a new panel. You're thinking, okay, how are we going to do this? Well, I created a file called benchmarks to help out. Now, here I'm going to use these here. I created some for other ones, for other web frameworks, but we're only concerned with Flask. So let's do requests per second first. So we're going to add a new panel, and we're going to title it requests per second. Then we're going here. So we're going here, we're going to do query options. So we're going to do something here. So hold on a moment. We're going to use Prometheus, which is our database. And we're going to add a query. So to do that, we're going to query. Now we need to paste an application. So to do this, I'm going to select metric, and I'm going to look for, and the one I'm going to look for is here. It's called Flask HTTP request. So Flask HTTP request created. So we'll go back to here, and it says duration seconds. So Flask request, so HTTP request duration, and it goes as seconds count. So we will copy this instead of me having to constantly look here. So we'll do copy, and we'll paste it, and then we will add, so we'll do operations. We're going to add rate. So we're going to add rate. And then we're going to do last 5 minutes. And there we go. Now we could always add, let's go to rate interval. And for rate interval, it's going to be 30 seconds. So we'll do 30 seconds. And that's it. So as you can see, this gives us the requests. And of course, we want to do this in microseconds. So we can change that as well. So we'll remove this here. So we can also change this to microseconds. So we'll go to unit, and we'll go under time, microseconds. And there we go. So as you can see, this gives us our time. Of course, we can also do status here, which doesn't seem to be here, but yes, we're doing seconds count. So now we're going to do another one. So we'll save, and we'll call this first dashboard, and we're going to save this. And as you can see, this is our first one. Of course, let's add a bit more activity. So we're going to blink the LED again. Let's refresh this. So we're going here. We'll refresh the dashboard. So it should show here. So this is just the first one. So let's get on to the next few dashboards in the next section. Welcome back. So I want to apologize for the last section. Turns out this is a newer method of calculating requests. So I'm going to show you each panel in the dashboard, but first I want to get you to this one. So as you can see here, we have the total requests per second. Now if we edit it, let me show you what happened. So what you do here is you look up the metric, in this case Flask, HTTP request, duration seconds count. Then you do a rate, a range of 30 seconds, and then you go to label filters, status of 200, and there you go. So if I run the application again, and then go back here, and I refresh it, see, it does that. So yes, I should have checked on that, but yes. Then of course, if we go to here, and as you can see, it increased because requests per second also shows up with an increase. And as you can see here, we have Flask HTTP request duration seconds count. Only this time it's at 30 seconds, and this is for all requests. So I just wanted to show you that. Then we have our RAM usage, which is here. So let me show you, which here is using process resident memory bytes, and the job is called LED monitoring. Then we have CPU usage, and of course if we go to edit here, it's called process CPU seconds total, and of course our range is at 30 seconds, and our job is at LED monitoring, and CPU usage is increasing and then decreasing because we haven't used our application just yet. Then of course we have average response time, which took me a while to know what happened, but turns out you have to divide here. So let me show you. So we have our Flask HTTP request duration seconds sum, status of 200. Then we divide by Flask HTTP request duration seconds count, status 200. And then of course we have our range of 30 seconds as well, and it gives us this. So it gives us our average response time. So the lower the response rate, the better. Usually an application will run better with lower response time, which means that the quicker it is, the less delay there is. Of course, if there's a huge delay, it'll tell you here. And that's pretty much it for our application. Now, this can be added. For example, you can also add another one here. In this case here, I added pod uptime. I forgot to show you this one. Let me just move it here. This is our last one. If we edit, we created a gauge, and we did sum up container LED monitoring by pod. So it will show us the pod uptime of our application, which is at 100%. You want it as a gauge to see if there's any issues. So if you see, for example, less than 100, then you probably do have an issue. It did drop off a bit because we're not using our application, but of course if we used it again, we're creating some things here. Let's simulate it by going back to status, and then we'll go back to our main application again, and then we'll go to our dashboard. Let's refresh everything, and as you can see, it updates. So this is it. This is our first dashboard. Now of course you can go here and we can import. We can also import our application, a new dashboard if we wanted, but we can also export this one as a JSON. So the way we go here is we go to home. So we'll go home here. We'll save dashboard here. We'll save again. And we can also make some changes here if we need. So we'll go back to the home. So we'll go to dashboards. So we'll look up LED. We'll look up first dashboard, and then we'll go to settings here, and then we'll go to JSON model, and here it is. Now I'm going to save this JSON model for anyone who wants to access it, so you can make changes of your own. So that's it for this demo. And that wraps things up for this entire series. If you made it to the end, congratulations. You now learn how to monitor your very first Flask application using Prometheus and building a nice dashboard with Grafana. Of course, you don't have to stop here. You can build a monitoring dashboard for your robot or your servo robot, or for any other Flask application you want. It doesn't necessarily have to be with output devices. You can use a blog you may have created, or a recipe website, or any Flask application, or even other web framework applications, and have it monitored with Prometheus. I hope you learned a lot from this entire series, and I will make this available as a playlist. So thank you so much for watching, and see you next time.